The binomial function in Excel is equals BINOM.DIST, and this command can be both cumulative and individual. If we do the individual ones first, BINOM.DIST, we have 0 successes, exactly 0 successes, 5 trials. The probability of success is 0.3, and these are individual, so I don't want it to be cumulative. And the probability of exactly 0 successes in 5 trials is 0.16807. I copy this down. Since I have the cell references, the probability of exactly 1 success is 0.306. Probability of exactly 2 successes 0.307, and so on. I can have the probability to be cumulative by adding up these successive probabilities. If I want the probability of 0 or 1 success, I add up those two probabilities so that 0.528 is the probability of 1 or fewer successes. I can also do this using the cumulative version of the command. This is equals Binom.DIST, where the number of successes is 0, 0 or less, there's only 0. There are 5 trials. Probability of success is 0.3, and this is cumulative. So I get 0.16807, which is the same as the probability of exactly 0. If I copy this one down, I get the probability of 1 or less is 0.52822, which I got before by adding the probability of 0 and 1. Probability of 2 or less is 0.83692, and so on. So the probability of 5 or less out of 5 trials, it covers all of them, is equal to 1. Now, on some instances, I want the opposite. I want the probability that x is greater than a value, or is greater than or equal to a value. If I do this, I have to take 1 minus these other commands. If I want the probability of greater than or equal to 1, equals 1 minus the probability of 0 successes, 0.16807, and I get 0.83193. The probability of 2, 3, 4, or 5 is 1 minus the probability of 1 or 0, 0.52, is equal to 1 minus 0.52. The probability of 1 or fewer is 0.4718. The probability of 3 or more is the probability of 2 or less subtracted from 1. Two or less, and so on down the line. So this is the probability of 4 or 5, which is equal to 1 minus the probability of 3 or less, which is here. In this, the probability that x is greater than or equal to 1 is also the same as the probability that x is greater than 0. The probability that x is greater than or equal to 2 is the probability that x is greater than 1. So it depends on how the problems are stated as to what the probabilities are and how they're interpreted. Also, the binomial is symmetric, so that the probability of success of 0.3 is exactly the same as the probability of success of 0.7, except it goes backwards, so that 0.168, 0.168, 0.36015, 0.36015, so that the 0.7 and the 0.3 are just the reverse of each other.